Hello, everyone. Welcome to the DLZP webinar for Remote Worker. We are going to give a couple more minutes to let everyone join, and then we'll get started. Hi, this is Lisa with the LZP Group. I think we're going to get started. I believe everyone is here. If you are not able to hear, please send a message on the Q&A and we will look into that to correct that. But thank you. Welcome to the remote workshop. This is being produced and presented by DLZP Group for the benefit of the state of Idaho and the counties and cities in the state, which is the Idaho IT Services Team, Ada County IT Team, and City of Boise IT Team. I would like to introduce the DLZP Group team. I, Lisa Brunet, is the president of the DLZP Group, which was founded in 2011. And then I have David Brunet, who is the vice president of the DLZP Group. He's in charge of our research and development. I have Bruce Burns, who is the senior management for business development, and he is the main point of contact for the state of Idaho. I have Brian Tharp, who is the senior manager of security and implementation, and then I have Nick Sefadashi, who is the solution architect. I would like to also introduce, we have a couple of our partners on the call from Amazon Web Services. We have Bruce Larson, who is the AWS account manager for state and local government, William Bush, who is the AWS Partner Success Manager, and Tyler McCleve, who is the AWS Solution Architect. Unfortunately, Tyler will be able to speak in a little bit. And Bruce Larson, have you joined and are able to speak? Okay, we will do an introduction at a later point of Bruce. Now I'm going to hand it over to Bruce Burns from my team, who will start presenting.
Great, thank you, Lisa. I appreciate that. Welcome everyone to this workshop. I know we're really excited about having you here today. I wanted to go over a couple of things, just housekeeping items first. We're going to try to end around 11:30 today, so there'll be no breaks. The idea is we want to get you back a little bit early. On the questions, as we go along, you can use the chat window in order to ask questions and put in questions that way. And what we'll try to do is we'll try to answer those questions as we go through online or at the very end of each section. There are, if there are questions that are really specific to your own implementation, what we'll do is we'll follow up with you after the session offline to go into those in detail. So today's agenda, this is the first of a 4-part series. Today is about the remote worker. And the reason why we focus on the remote worker up front is because of the current virus situation. We wanted to move this up because so many people now are needing to work from home and being able to work remotely. So that was the idea of today's session. To kick off today, I have a Cloud 101 overview that we'll go over, just a little history and a little bit about the cloud. I think it's a good primer for the topics. After that, we'll double click on the remote worker more on remote cloud desktops using AWS Workspaces, Amazon WorkDocs for secure content collaboration. We'll also talk about AppStream. It's a way of being able to remote applications and being able to share them. Amazon Chime, which is a virtual voice and web meeting facility that Amazon provides. AWS Cloud 9, it's a cloud-based IDE, a development environment. We'll provide an overview of that today. And then in 2 weeks, we're going to do the deep dive on that. And then AWS VPN, a way of extending your on-prem networks into the cloud for secure anywhere access. So that provides a quick overview. I'm going to now transition into the first deck, first series of slides. And this is really about the cloud. A lot of people, ask, what is the cloud? I had somebody at State of Idaho ask me, where is this thing? And what exactly is it? Because the cloud is somewhat nebulous, if you will. And I wanted to try to clear that up. We're all IT professionals. Some will have more experience than others. I've had the luxury of being able to be in the cloud business for over 10 years now, starting at Microsoft with Azure, and then moving over to AWS and working in the AWS team. And now I'm working for DLZP. DLZP was a partner of mine when I was at AWS, and I now have the luxury of actually working with DLZP. So I wanted to provide some context on how the cloud is, who uses it, why it's used, when it's used, and then how. So I call this 5 W's and an H, if you will. It's just a quick primer. Okay, so what is the cloud? Well, the academic definition is cloud computing is on-demand delivery of IT resources. These are compute network and servers or an application that you can use using pay-as-you-go pricing. So this is different from previous generations where you had to buy the infrastructure yourself, host it, and run it. This is you can just click to launch and start using this infrastructure off of the cloud. And quickly what comes up is, what does cloud mean? What is the name? So a little story here, a little history is that, as IT professionals forever, we've been drawing diagrams where you might have a workstation here, and that workstation might go up through the internet, which we basically use the cloud as a diagram for the internet, and then down to on-prem. And one of the things that was found here is that this time to go from here, from the client up to the cloud and then down to the server, it took time. That could take customers have done is that they actually have been able to, if you will, customers found that they could move those workstations, a compute network and storage resources into the internet itself. And so what happened is, what happened was they moved those compute network and storage resources into the cloud. And what happened is the latency from the client workstations was sometimes cut in half. So if you could actually move this environment into the cloud, it was easier to use and manage. So that's where the name cloud comes from. It's actually from the internet icon itself. So the question is next is, okay, well, where's the internet and where is the cloud? So, you know, when we think about the cloud, it's located in these large warehouses. You know, for Amazon, I think about these large fulfillment centers, but rather than filled with boxes, they're filled with servers. In closest to Idaho, it'd be Umatilla and what we call US West and GovCloud. And those facilities are in Umatilla and Boardman, Oregon. They have 6 of these huge warehouses that are installed and up and running, and they represent millions of virtualized servers, around 3 million servers that are there that customers are using. These servers can be provisioned, used, deployed in seconds to minutes, and they can actually be then stopped and passed on to the next person. And this all happens very rapidly. And this is part of the agility. Some of the value of the cloud is this agility of being very rapidly being able to provision and use these types of resources from the cloud. Just a little bit, okay, what exactly does that mean? Well, in the cloud, there's 3 different types of architectures, if you will. The first is standard. It's infrastructure provided as a service, and sometimes they call that IaaS. But it's basically compute, network, and storage. These are servers that are connected together that you can run a traditional workload on. So any application that you run in a data center today, that your own data center today, you can run those in the cloud by being able to lift them and shift them over to the cloud, or be able to do a clean install in the cloud of the application, just as you do on-prem. Those servers look just like the servers that you have that are running down the hallway in your own data center. The only difference is that they're actually running in a cloud provider's data center, in this case, AWS. So that's infrastructure provided as a service. Second is platform as a service. This is where we raise the layer of abstraction up, and we're able to provide both database and application platforms to be able to run. These are more cloud native or microservices based infrastructure that you can just use to be able to use a container-based or a serverless-based workload. We'll talk more about that. And then the third way that the cloud is used is just providing it as a SaaS service. So you just use it. You don't have to manage the application workload, you just use it. Examples would be in the AWS world might be workspaces for sharing documents, for sharing desktops, work docs, or Chime, remote communications. Office 365 is an example of this from Azure. Another example would be Infor. The Luna project is using Infor running in the cloud. It would be an example where it's provided as a service. The IT staff doesn't have to worry about patching and maintaining these servers. They just have to worry about configuring the application itself, but not the underlying infrastructure. So these are the 3 different types of cloud environments that are out there. They're all coming from the same data warehouses. Okay, so where is this cloud? And it's kind of an interesting story here. The cloud basically used the railroad lines. So if you look up here, these are some of the long distance carriers that we have out there today, Sprint, AT&T, etc. And in the 1800s, the railroads came through. And then quickly after the railroads, the telegraphs followed those railroad lines as a way of being able to communicate. And it revolutionized, that technology revolutionized the late 1800s. And then in the 1900s, those copper lines were put down in order to run telephone lines, long distance telephone lines. And then in the 1980s, they were upgraded to fiber optics. And so all these lines were run for these different telephone carriers and data providers. And what happened is that there are certain spots where all these lines come together. So what this is, whoops, sorry, a little delay here. What this is a map of the United States. And this is from the University of Wisconsin. And if you overlay, all of the different long distance carriers, you'll notice that there are certain places where they all come together. I've marked those with a little router sign, a little X. And these places are unique in that multiple long distance carriers come together. And what happened is in the 1990s, companies such as Equinix, CyrusOne, Digital Realty went and bought property, the physical property where these lines come together, knowing that these will be very special places. These are low latency, high bandwidth connections for the internet. And in these locations that cloud providers first started renting and then started building their own data centers because of these very high speed connections to multiple long distance lines. So each of these X locations are just a natural place where things come together, and you'll find either public cloud providers or large internet companies such as maybe a Facebook will have their data centers in these locations because of that connectivity. Now, if you look at the population density of the United States, it's another variable for where cloud providers are going to put their data centers. Obviously, on the East Coast, there's a lot of density on the East Coast. There's also density on the West Coast. And if you take together the variables of where do these networks come together, where are the people located, and then a third variable, which is where is the cost of land and electricity low, you'll find those areas are where the major clouds are. So for there's typically a major one on the East Coast for Virginia area that has the lowest cost of land and power, yet it's very highly connected because basically because the train systems were there in the 1800s and their junctions that built out with all the long distance carriers and can service these high density populations for the East Coast. So for AWS, that's US East 1. On the West Coast, those two areas that really make sense are actually in the Portland area, a little bit east of Portland towards Boise, in Umatilla. In that area, different providers will be in different towns, but it gives you a feel. In that area, obviously the electricity power is cheap because of the Columbia River, land costs are low, and it has the critical network connections. So that's why the cloud is in that location. There's also one in the Silicon Valley area and San Jose area where those lines come together. The land's not as cheap and the power is not is a little more expensive. So you'll notice that the cost of using the cloud out of that California facility, US West 1, is actually a little bit higher. And that's because of that. But the density is there and keeping the latency real low and the user experience really high for using that environment. So a little background about where the cloud is for at least the United States and how it was built and how that comes together. In addition to the public sector, there's something called GovCloud. There's one on the West Coast out of the Oregon area, in Umatilla, Boardman area, and then on the East Coast, again, where these clouds are dedicated to public sector companies or organizations, excuse me. So public sector can use it in their own secure environments. Next question is, who uses the cloud? You know, when I think about TVs today, they're all smart devices. If you go and buy one, I don't know that you can even buy a non-smart device TV anymore. And if you do, then typically customers, you know, put on an Apple TV or a Fire Stick or something like that to get it internet connected. But any internet connected TV or Xbox or game console or these voice assistants, all of these internet devices all use the cloud for streaming content, whether it be Netflix or Amazon Prime, etc. Also, of course, cell phones, tablets, everything up to a workstation can use those same services, but in the office environment for the public sector, from these cell phones, tablets, computer systems are used for services such as Office 365 or Amazon Workspaces, all the way up to say for Infor Cloud Suite for the Luna project for the state of Idaho. So all of these are provided as a service from the cloud to these devices. And I will say that these devices could not exist without cloud-based computing. That can only happen there because of the rapid deployment and ease of being able to scale up and down and the low cost. All right, so I wanted to give you a little preview into AWS. Amazon is a leader in cloud services, in the cloud. They were the first to market, and they really pioneered this concept some 10 years ago or so. They have 22 regions worldwide now, with 69 of these data centers that I just talked about. They call them availability zones. $35 billion in revenue last year, with a 27% growth rate that was projected for 2020. Now, it'll be interesting to see what happens here, whether they continue to grow at this high rate, or if it's lowered because of the virus. Now, my prediction is that the rate will continue to grow high. And the reason why is when we have an economic downturn, typically new technologies are the ones that take off. We saw that with mainframe with the downturn. We saw that with client server and the internet. I'm predicting that that will happen again here, where because it's faster, cheaper, and easier to use, that companies now will continue to actually to go faster into the cloud because of those savings. AWS today has 1 million active users, customers that are using the cloud. These aren't end customers, these are organizations that are using the cloud in 245 countries. And to give you a size for AWS, because they had this head start, they have 5 times more deployed infrastructure than the next 14 cloud companies combined. So if you took Microsoft, Google, Oracle, IBM, etc., the next 14 competitors and combine them, they still have 5 times more compute, network, and storage, more servers that are out there than the next 14, which is mind-boggling, at least to me. Today, they represent 41% of the public cloud market, and they're bigger than the top 4 competitors combined. So if you take Microsoft, Google, Oracle, combine those, one other IBM, combine those, they're still bigger than the top 4 combined in terms of revenue. Netflix, as an example, is an AWS customer. And on any given night, when folks are at home watching TV, up to 1/3 of the internet's traffic in the United States is actually coming from those AWS data centers for running that one workload alone, Netflix. So it gives you a feel for scale. Much of the internet is built in these data centers in AWS. AWS has 8,000 partners in their partner network, and DLZP Group is one of those partners. We specialize in helping customers move workloads from on-premise into the cloud and optimizing those workloads. So that's a little bit of overview about AWS. This is a Gartner's Magic Quadrant. They provide basically a view as to, as an industry analyst on, leadership in this space. What you'll see is the top right-hand corner shows the ability to execute and completeness of their vision. AWS is in that top right-hand box and has been every year since it's been published. Azure and Google are also leaders, or below and to the left. And then some of the more challengers or niche players that are in the bottom left. So this just gives you a feel, and AWS got this lead because basically they disrupted this IT environment. Just like VMware disrupted servers that are running on an operating system, AWS disrupted servers that are running on-prem, rather providing them on cloud, providing a better business value proposition to clients. Now, one of the things that's interesting about this is that sometimes these data centers are actually already owned by, say, a CyrusOne or an Equinix. And so you may have 10,000 or 100,000 servers for AWS in part of that campus or part of the data center, and then may have Azure also in that same campus or data center. And you'll get this capability of being able to do cross connects. And what a cross connect basically is the ability to be able to take a cable from one of these environments and literally drop it into the other. So you can take a direct connect, get a direct connect, 10 gigabit connection, and take one of these yellow cables and run it directly over to Azure. And basically what happens is you get one line from Azure, which would be called an express route connection, and get one line from AWS, which is a direct connect, plug those both into a router, and then you can basically connect those two cloud services together at very high speed and low latency connections, like in the a few millisecond connections. So it is possible, and customers are doing this quite often, to be able to have these high latency, high bandwidth connections at a relatively low price between the two services, and then use NPLS to bring that down to their own data centers. So you can combine these three together these days in a very straightforward fashion. It's kind of fun stuff. All right, so what is the value prop for using the cloud? I think it really comes down to a version of it faster, lower cost, and a better way of being able to do computing. On the fast side, we're able to get a new set of servers up and running in minutes to hours. And before, in the client server world, or even with virtualization, it may take weeks to months to provision the equipment, to write a PO, to rack and stack, to get it ready, to load the hypervisor, and then to launch the virtual OSs and installing those OSs and get it all configured and ready to go. In AWS, that is, and in the cloud in general, and AWS in particular, that's all automated. AWS has something called CloudFormation, which is a JSON-based scripting environment, and you basically write the code to be able to launch the environment that you want: compute, network, storage, the images that you'd like to be able to launch are all defined in code. You run that script, and literally within a few minutes, you can have an entire new instance of any workload up and running in minutes to hours. And it's that business agility which is really driving a lot of the cloud, because if you need a new instance for dev, test, or for a training class, or for pre-production, that can be done now without having to, in minutes, by running the script to do it. It gives you very consistent deployments. And it also is a very low cost way of doing it, because say after the class or after your development experiment is done, you just run the script to bring down that stack, and you're no longer charged for any of it. So that's one of the big advantages, I believe, of what's driving this, is just that agility, that business agility, to be able to scale, to be able to launch in these environments using code in that way. The other part of it is just the architecture is a little bit different. Rather than scale up, where you have these big, large, huge servers, the architecture is more of a scale out, where you have multiple small servers, and you can scale out the number of servers being able to on demand. So as traffic goes up, you can use load balancing to be, and then auto scale to be able to launch new instances. As the load goes down, those instances are terminated. You're no longer charged for it, and you have consistent service with a low cost. So the business model is a little different for the cloud. It is pay only for what you use. People call this a utility pricing model. Going back to the 1800s, when those phone lines came in, or excuse me, when the telephone, one more time, when the trains came through in that era, there were no power lines. Idaho Power didn't exist to begin with. And if somebody wanted power, they actually had to buy their own power generator and provide in a powerhouse, literally, that would power, say, a sawmill, or a mining camp, or it would power a factory. And then what happened is utilities came through, such as Idaho Power, and said, hey, look, we can provide the power. You just pay for what you use. We'll meter it and just pay us that way. So rather than having that big capital expense to buy that generator, that powerhouse, and to operate it, you can just pay an operational expense of being able to pay for what you're actually using power-wise. The cloud is exactly that same analogy, where you can instantly provision or consume as much compute, network, storage as you require. You're only billed for what you use, and then you can turn off the lights, and that bill instantly stops as well. So it's this utility pricing model, which is a game changer on the business front. It moves it from a capital expense, like that powerhouse, to more of an operational expense, OpEx expense, more like using a utility such as the electricity from Idaho Power. The third part of it, why people are using the cloud, is just the better part of it. Some applications could not be done on-prem. They just couldn't be built. Can you imagine trying to build out an Uber or a Netflix on-premise, where you don't know what your peak load's going to be, you don't know when you're going to have a run, and the expense of being able to do that. So being able to have high availability and be able to provide disaster recovery as well, where you can set up, you can run that script in US West as an example, but then run another script in US East to bring up the same system as if you have a fault, and you can automate that. So the availability of being able to have high availability of having multiple instances, and then having a backup, a disaster recovery instance in another data center, is part of the architecture, and it's of the cloud. Another advantage is the analytics and artificial intelligence that comes with this. Being able to make data-based decisions is becoming critical for organizations of all shapes and sizes. And those services are being provided on the cloud first. And then I think the other thing, and this is interesting because when I started, security was one of the reasons why people were a little bit hesitant about coming to the cloud. Fast forward 10 years later in the industry, and it's now a reason why people are moving to the cloud, is that because of higher security demands, cloud is able to provide that. And let me speak a little bit about that. For AWS, here are some of the security credentials and certifications that they support. Everything from SOC 1, 2, 3, through HIPAA to FIPS 140 to NIST. These certifications take a ton of time to do, and they're very expensive. But as a cloud provider, you can amortize the cost of doing these security and privacy certifications across many, many customers. So as a customer, you get these as part of the service. You get the infrastructure, which already has these security credentials and certifications to begin with. And it just makes being able to provide a secure, robust environment that much easier, because this is an added bonus of being able to use the cloud. So today what we're seeing is customers are moving to the cloud because of the security certifications, and because it's a more secure environment than running it on-prem in general. So, okay. One thing I've noticed also is that in our industry, the bar is raised on what users now expect out of software. You know, it used to be that somebody expected to use an IT system. It was, you know, had to go through a lot of training. It was very difficult to use, but once you get through that and you understand how to do it, maybe you could use it. But now with cell phones and with cloud-based services that are out there, such as on the left, Uber or Maps, or even Amazon, you know, the retail shop. If you go to those sites, they're intuitive. There's no training manual. There's no instructions. They're just simple to use, yet extremely powerful. And what that's done, I think, for our industry is raise the bar on the expectation of our users on what a good user experience needs to be. And these applications can reach that bar, or have been able to raise that bar, because they don't do the undifferentiated heavy lifting of, you know, of providing the infrastructure itself. They're able to focus their time on polishing those applications and making them super easy and efficient for customers to use. All right. So I had a little pause here. Sorry about that. Okay, here we go. We've gone through these eras of computing now, from mainframes starting in the 50s, 60s, and 70s, to client server in the 80s, to distributed VMs in the late 90s, to now public cloud in the 2000s. And in the cloud era, there are well, being able to use existing client server applications that were running on VMs in public cloud, and now more cloud optimized, or what are called serverless applications, using container and other technologies to be able to provide it. What we're seeing is the cost of the workloads are dropping an order of magnitude for each of these eras, as one might expect. And that's a big driver. And the other thing that's happening is just the time to be able to deploy these new workloads is now being cut down. Those are being able to do more with less is becoming super critical, especially in this environment. And so that's, that is happening, as well as this the velocity of change itself. So, we need a new application. We need, the agility to be able to launch at new instances and get them up and running quickly is really powerful. So between lower cost and higher agility, those are the things that are driving cloud use. And the reason why is it is when customers need to be able to transform and modernize their environment. So government IT transformations, such as the federal government, they have something called Cloud Smart, and it's the federal IT strategy to accelerate transformation by using these cloud-based technologies. State of Idaho has a modernization initiative underway to be able to modernize. And that's one of the areas that cloud is typically very much used for. Developers of applications, whether you're an IT internal line of business app that you develop, or off-the-shelf commercial software developers are using the cloud and supporting it first. So now when you go to buy a new software package, cloud first is kind of the mantra. And there's 3 different ways that applications can support the cloud. The first is being able to run on cloud just as you would run on-prem in a virtualized environment. But instead of using your own compute network and storage, you're using the utility that within the cloud to run it. So it looks exactly like on-prem. There's advantage of that because you already know how to run it that way. And it's pretty simple and straightforward to get your existing apps to run in that way. But there are disadvantages as well. And the disadvantage is it's not as cost effective as if you have a cloud native solution, which is number 2 here. So cloud native, or these serverless implementations, rather than using a virtualization as the isolation layer, so you're using a virtualized instance, say with 4 cores, you're able to abstract that up a layer in such that you're using containers or serverless. And the advantage of that is that you can lower your cost further by using that type of technology. And then finally, just providing the software as a service itself and being able to offload it is the third way that the cloud is being used. I'll use State of Idaho as an example. They have their Luma project from the state's controller office, which is running in AWS. It is using Infor, who provides it. So really, they're working with Infor. The fact that it's running from AWS isn't really that prevalent. That's just happens to be where it's hosted. Infor provides Cloud Suite as a service. State of Idaho ITS or the controller's office uses Cloud Suite and runs it in that way. So those are the 3 basic ways that we're seeing the applications to be used. So what I'd like to do now is transition here and have Dave talk a little bit about a couple case studies.
Sure. Thank you, Bruce. My name is Dave Brunet, the VP of Research for DLZP Group. And so we wanted to talk about a couple different customers that we work with. The first one being Canon Information and Imaging Systems. So they had an imaging solution that was designed for procurement processes, AP primarily, processing invoices and sending them through into the back-end ERP automation. So we were working with them and we built their integration to Oracle applications. And so that was all good and great. But the challenge we kept running into is we have a lot of customers that are very small that process maybe a couple hundred invoices a month. And that type of solution that they had used a lot of technology that was very expensive. They had licensed software licenses from different partners to kind of build the solution. So it had high volume processing built into it. So what we did is we worked with them to identify, well, where can we reduce the cost of deploying the application? And so we were able to actually take their application and get rid of all the pieces that were adding to the cost. So rather than it being a $130,000 solution that had to be, you had to be a large corporation of $500,000 in revenue or greater, we were able to make it a scalable solution so that we could scale it down to a customer that only had a couple hundred invoices to process a month, and we could send them through the imaging software. And then their cost would be, a few $100s a month versus a larger scale company that was processing 1 million invoices a month. They would pay a few thousand a month versus, so that's the scale of difference. So it reduced the cost of their solution by over 70%. So that's the first case study. Go to the next slide, Bruce. The second case study is a client that we worked with. It's a medical telehealth type provider. And so they had built their solution on premise and they had reached the scale that their infrastructure could support. So they were actually growing really fast. So they engaged with us, and it was about 90 days out before they were going to win a new contract that was going to double and possibly quadruple the number of customers they had to serve. So they were serving about 1.8 million with their existing architecture. They were expecting to serve 10 to 20 million customers over the next year. So what we did is we worked with them, and what we did is over a period of 45 days, we re-architected their solution using 100% serverless technologies on AWS. So we converted everything to run on AWS Fargate, which is a container-based managed service that AWS provides. We also deployed it using a serverless database on the back end. So it was just using Aurora, AWS Aurora database, MySQL server for all the data. So basically we took it, and the cost of what they were running on-prem versus what we were on in AWS was a little cheaper on AWS, but the beauty of it was they could scale infinitely, okay? Because the way it scales on AWS is you just say, hey, what's the minimum number we want to run and what's the maximum number that we want to run? And then it'll just keep jumping between those numbers as you grow. And if they need to grow faster or they need more resources, they can increase the upper number. So basically they got the same solution. They got it for less than or equal to the price that they were currently paying, but they got the unlimited scalability that they were looking for. And in addition to that, there was a bunch of HIPAA compliance requirements that they had to meet, that by moving them to AWS and leveraging the certifications that AWS had, they inherently earned those HIPAA compliance certifications as well. So everything was secured. One of the neat innovations that we did with them is we actually have this architecture changing the password daily. So their password policy now is, that all the architecture, no one knows the password. It's, it's protected behind the scenes, and it changes daily, so that, which was a neat little feature that we built into it. So hand it back to you, Bruce.
Okay, great. Thank you, Dave. I'd call this medicine as a service. I know my doctor is going to the same thing given the current environment today. All right, so I'm going to go ahead and try to get this wrapped up here with the last question, the H and the 5 W's and an H. How is a cloud used? Really, this is, in summary, is to take existing workloads that you have right now and be able to migrate them, lift and shift using the compute network and storage that's in the cloud itself. The second way is to be able to refactor existing applications using more platform services, using these more cloud native or container serverless based applications and databases. The third thing is to be able to retire old apps altogether and use software as a service from everything from Office 365 to Infor Cloud Suite, financials, and more. So with that, it pretty much concludes the overview. I wanted just to provide just a little bit about DLZP. We are an 8A SBA certified women and minority owned company focused on the cloud with AWS. With now 8 years of experience of working with AWS from the early days. The mission is to be able to lead and evolve, to make a positive impact for our industry and community. And the vision is to be able to continually innovate and educate, provide products and services that meet the challenges of today. So that's a quick overview about the company. The services we provide are around cloud advisory, cybersecurity, applications to migrate them and be able to provide remote worker support, and security, really around compliance, secure by design implementations, analytics, building data lakes and being able to then query that to get database decision support. And on the infrastructure's part of it, being able to do architectural design and implementations, and then to be able to do those implementations or manage them for you, and then being able to provide training. So a little bit about State of Idaho agreement. DLZP was recently awarded a contract that allows for any state-based organization, any county or any city, to be able to use a pre-negotiated low-cost pricing for AWS. We're able to provide it and then be able to do value-added services on top of that. Hence the conversation today. So what I'm going to do is open up for Q&A right now. I know this is the overview and summary part, but I thought it was good to be able to provide a little bit of context on the 5 W's and the H. So, questions? All right. Okay, the first question that is up, will we share presentation slides following the session? And Dave, would you like to answer that?
Sure, yeah. Yes, all the slides will be shared after presentation.
Excellent. And then second question that's up is just a request. From the AWS folks, you know, I talked about the networking topology and kind of the history of how these networks come together. We'll have AWS has regions in some of those areas. I covered those in, for example, US West and out of the Oregon area, also out of California and on US East. And then one which is out of Virginia and two which is out of Ohio, Chicago area. The other locations, there are also something called points of presence, which are basically direct connect locations where you can get a cross connect between to the cloud. So you can use MPLS to connect directly into the cloud, or you can do a cross connect to connect two clouds together in those points of presence. Typically, it's used for customers to be able to use MPLS to go to a point of presence and then have a private network connection, very low cost, high bandwidth, secure, so it doesn't go over the internet, connection into the cloud itself. Third was, hey, I thought just a little bit of feedback. It's like, hey, this is kind of general and it's too much sales. I wanted to provide, and I apologize, I wanted to provide a little overview. We will go now more technical moving forward, but I thought it would be good to be able to provide just a little bit of overview on the cloud itself. And on that point, I think that is all we have on the Q&A front. So what I'd like to do now is move on to the next section. But before doing so, just a couple best practices for working remotely. These are some suggestions that have come, 12 healthy ways of working from home. Now that we're all working from home, or so many people are, and the next section is on remote workers, I thought I'd just review some of this stuff. It's kind of interesting on how to best do this. This is a new skill for many people. You know, everything from setting up a new office space, a separate office space for being able to do work. So you have that's there, where you have a good chair or a way of being able to work, and getting up at the same time every day and be able to work just like you would, you know, get up just like you'd go to work, but you just get up and go to that office space in your own home, are very helpful. To things like just maintaining a healthy lifestyle by you know, setting limits, so you're not always working or you're not working enough. You just set those times and set those limits to be able to work. To things like, you know, use the same routine as you've done before. You know, getting up, showering. Instead of go to the work, you just go to your office, just like you know, your office in your house rather than home. And then it's interesting to be able to get involved in some virtual telecommuter communities to be able to share best practices. So this is a new skill that's coming up. So with that in mind, what I'd like to do now is transition over to Brian Tarp. He's going to take us through now on the double click on more remote working. So Brian.
Thank you, Bruce. I appreciate it. Good morning, everyone. This is Brian Tharp. I spent 16 years in the financial services industry working for Bank of America. And we put a lot of capital investments into building business continuity solutions so that a customer would always be assured that they'd have access to their money. At no time during any of those years did we ever plan to have 100% of our workforce working remotely. So to say this is unprecedented probably is quite an understatement. So as I'm trying to get, okay, I've got control. Thank you, Lisa. So we wanted to talk about some virtual ways that you might be able to keep all or a portion of your workforce working remotely. Personal use has always been quite interesting for organizations to allow personal devices to interact with organizational infrastructure and data. I want to say how some of those issues can be eliminated with some of the solutions we're talking about today. There can also, typically the way remote workers engaged with organization IT infrastructure was through network and VPN solutions, and there can be some capacity constraints because again, those weren't sized for a 100% remote workforce. And then also we want to talk about if there are some options that we may have of interest to you, we need to make sure that they're very easy for your end user community to use. So unquestionably, anything that you do for your remote workers has to be secure. We don't want to provide any large attack surfaces for bad actors to take advantage of. I don't know many companies that would have the capital required to make an investment to get all of their remote workers engaged with laptops or other resources that would be company owned so that you could manage that infrastructure with hardware-based solutions. So we're going to talk about some virtual pay-as-you-go solutions today, how these resources have the value of the cloud so that they can scale up and down depending on demand, and they can solve problems for you very rapidly. Also, with respect to the personal devices, we know that there's a lot of security risks if you use personal devices integrated with organizational infrastructure. We're going to talk about how that can be accomplished without creating any new undue security risks. Even if you did have the money, there's probably not enough hardware in the pipeline to support every business's or organization's need in the US today or even across the world. And if we're going to think about leveraging personal devices, we need solutions that are going to support multiple platforms. And it is required that they would be able to isolate any personal compute from your corporate infrastructure. And again, we'll be talking about some solutions, some virtual solutions that will maybe get you through the surge in need for VPN and remote access to your on-premises environments. You may be having issues from both a hardware or a licensing level with some of your VPN infrastructure. And so we'll discuss that for a few minutes. Oops, sorry. Okay, and then finally, anything that we present has to be super simple for your user community to engage with. It shouldn't require any retraining, and it should be complementary to what they do on premise today. So specifically, what I'm going to kick off talking about this morning is for compute, remote compute is Amazon Workspaces. We're also going to be talking about the Amazon WorkDocs, which is a remote file sharing solution. And then I'll hand it over to some of my teammates to talk about Amazon AppStream, Amazon Chime, AWS Cloud9, and the AWS VPN solutions. And then we're going to just touch real quickly on something. I don't think anyone has a crystal ball and knows exactly what's going to become of how this virus affects us in the future. So there may be some forward-looking people in your organizations thinking about that, and we are just going to touch on a couple of solutions that may give you some options that you previously didn't have with on-premise solutions. So I'm going to dive into Amazon Workspaces here. Amazon Workspaces is a cloud virtual desktop. I'm presenting a Windows, basically Windows 10 desktop. Super simple for your customers to use or your organization to use. We can deploy these desktops in about 20 minutes, and the beautiful thing is they're pay-as-you-go. There are both Windows and Linux varieties. We can scale to thousands of desktops across the country or across the globe. There is a mature managed interface for your IT administrators to manage these desktops. They can be configured in bundles so that you can bundle application sets based on the discrete needs of various users and user roles. They will integrate with your identity infrastructure, Active Directory, and other means to be able to take advantage of the security infrastructure you already have in place. And they support secure and encrypted access to your environment. And they are capable of supporting restricted data types like HIPAA and PCI DSS. From an administrator perspective, there is a mature enterprise administration platform. Again, you can create multiple bundles of desktops so that you can align the applications with the user community based on their usage. You can package and deploy any applications that you have built internally. You're able to upload applications that you own the license to, and you're able to subscribe to other applications through the AWS Marketplace. And from an administrator level, we take care of managing the versions of the desktops, but we do provide usage metering and custom images, our capabilities for your administrators to deploy to your workforce. Super simple to launch new workspaces. I'm on slide, or basically step 2 and 3 here. On these two screens, there's a lot of flexibility in the type of VCU capability and RAM memory capabilities that you have for your end users. There are some free tiers available, and then just a few selections that need to be made to really get that desktop launched. So I'm going to pause here for a second and let Dave say a few things about how that desktop might interface with your organizational environment. Dave?
Sure, no problem. So what we got here is just kind of a reference kind of architecture that you may or may not use, but it's just for discussion purposes. So the workspaces get deployed into an AWS VPC. That VPC then has access to your potentially your internal resources. We can set up security so to allow certain types of apps through. So you got a lot of flexibility in the way it gets deployed and the way the users access. As you can see from this diagram, users access it through the internet, through the front end endpoint. It's an app that gets installed in the client's workstation that they click, they log in, and then that app is actually secured from the client's workstation data. And if you enable some policies that restrict what type of activity they can do on that session, then they won't be able to copy files down to the local workstation and things like that. But it gives you the ability to kind of provision desktop sessions to users And the nice thing about the Workspaces client, it works across devices. And I think you may have a slide about that or already passed it, Brian, but they could run it on tablets, Chromebooks or Windows devices or Mac OS. So it works across platforms as well. Okay,
So
Brian,
moving
back to you.
on, thanks, Dave. Moving on, as Dave said, it works on a variety of platforms. From the user perspective, they're going to get an email from the system with a link to download the appropriate software for their desktop to launch and run the workstation. And essentially, there's one registration code that they need to put in that new platform to gain access to it, and then they would use their already established credentials to be able to gain access to that desktop in the cloud. Just real quick on pricing, what we're sharing in the presentation is just the list pricing from Amazon. DLZP Group does have a special pricing and terms established with the state of Idaho. So this is just as a reference to kind of give you an order of magnitude. There are a large variety of a number of workstations that you can choose from. I just took a couple out here just to give you an example of what they cost. You can see the number of CPUs and the RAM over there in the notes column, and then they're outfitted with a minimal amount of both root and volume storage, but that can be enlarged. And in fact, the volume storage that they use is Amazon WorkDocs file storage, which is the next topic that we'll be talking about. And there's really two choices. You can either choose a monthly pricing option or an hourly pricing option. And certainly for any remote workers that are going to be working 100% out of their home for the foreseeable future, the monthly pricing option is the best option for your choice. For really low impact workers or workers that just need access once in a while, there are lower hourly price options. There are some bring your own license options in the pricing as well. And you can also procure additional disk space for very inexpensive rates as well. Okay, so the Amazon Workspaces provides you a secure cloud desktop. It's a pay-as-you-go model. You can set up the applications that you need to meet specific user needs or user roles. And it's really simple to use on a variety of devices, and it addresses those security concerns that we all have if we were to use or leverage some user infrastructure, some user devices to interact with our infrastructure, our organizational infrastructure. So I'm going to pause here and see if there's any questions. If we please use the Q&A panel to answer any questions you may have about this. And I'll give it a minute, and then I'll...
Hey, Brian, there was a
Yes.
question. There was a question about, for workspaces, what infrastructure services need to be in place at AWS to make the desktops look to users like they're on our internal network. And so really that would be, you would gain access to the workspaces either, if you want to, you can force them through the VPN. So then they would click onto the VPN and access it. And that would be one mechanism to secure it. Or you can make it accessible publicly where they can install the app and then they log in, and then it's kind of virtually VPN'd into the network because they're authenticating through your authentication mechanism. So it can be connected to your Active Directory server and that. And then, just the look and feel of the images, you can create your own custom images. So I think there's a couple questions in there, but hopefully that kind of got you the context, or at least close to the answer you were looking for.
This is Tyler with AWS. One of the other things too, when opening that up publicly, most customers opt to use multi-factor as a method for, something that something that you have. So adding in multi-factor for any of those workspaces that are publicly facing.
Thanks, Tyler.
Okay, any other questions out there? Okay, we'll have more Q&As throughout the session. So if the other thoughts come up, please share those with us, and we'll make sure that we get them answered for you. I'm going to move on. All right, so Amazon Workdocs. Amazon Workdocs is an end user and team file storage infrastructure. It can replace your legacy network file shares. It is a secure and auditable environment, and it's really great for team content and collaboration. It leverages the global availability of the AWS infrastructure, and it provides a fully managed secure content creation and collaboration service. It is compliant, as I mentioned, just like the workspaces. You can secure sensitive workloads in this environment. So it's HIPAA, PCI DSS, to name just a couple. It's fully auditable and meets those certifications listed there, the ISO certifications. You can choose the residency options of where you'd like your data to be stored. For Idaho, it would likely be in Oregon, but there are other places in the US as well where data could be stored. You're also able to add data retention policies at both the file and the folder level to have your data, to manage your data and manage the amount of storage you're using. And then you're also able to make it look like a drive letter on your system, so it can be engaged much like your users were used to using their on-premise network file storage through a drive letter access. I am, here we go. There's some, oops, sorry folks, there's a little lag in my screen. So some of the benefits, you can migrate your on-premise file servers and kind of get through the capacity treadmill that we've all battled when we've had to try to manage storage capacity on physical machines on-premise. You're able to you're able to securely share both with your internal teams as well as any external users to your organization. You can give an external user access to a single doc or at the folder level. You can access Amazon Workdocs via Windows File Explorer, Mac Finder, or web browser. And as I mentioned before, you can attach to it via a network share, a lettered network share. Here's just a couple examples of a browser view and a Windows file view of the workspace. So to give you some idea on pricing, there's a discount for people that are using Amazon Workspaces. You can get the first terabyte of data for $2 a month for those workspace customers. Amazon's also offering 50 gigabytes of free storage space for workspace users. And then if you were just interested in the Workdocs infrastructure standalone, you would be able to procure storage space for $5 a terabyte a month. We've got some other information below that, a little bit more detail about the infrastructure, and also down in italics, there's some information about some specials that Amazon's offering right now, and those will be discussed more fully at a later part of the presentation. So just to review, it can be integrated with Amazon Workspaces. Workdocs provides a secure and auditable environment for sensitive data, and it's super simple for your users to use on a multiple of platforms to gain access to their files and documents. So any Q&A on the Workdocs portion out there, folks? Give it a minute.
So, just to note, one of the interesting things about the pricing is the additional storage space above the 1 terabyte that's provided for that fee is priced at regular standard S3 price rates. So very low cost storage. It's under like 3 cents a gigabyte for anything above 1 terabyte per user. So.
All right, I'm not seeing any Q&A on that. So Dave, I think this is when we roll over into some of the topics that you're going to be discussing. So thank you, everyone.
All right, so I'm going to talk to you guys about AppStream. So slightly different than Workspaces. Workspaces was focused on giving a full desktop experience to the end user. And so they had, they could have Windows with Office and all their individual apps on there. AppStream is taking that to the next stage down, where you actually stream individual apps to users. So AppStream is a fully managed application streaming service. You can centrally manage the apps for your users and control access to who gets them. It's over a secure network, and it allows you to scale across up to any number of users. And so it doesn't require any additional provisioning or anything of hardware. That's all handled behind the scenes automatically through the AWS solution. Next slide. So some of the features, it's very simple to use. So if you're familiar with Citrix or other types of technologies that do this, basically the user would install the little app on their desktop, and then they'd be able to pop up and say, hey, which app do I want to launch? And so they can launch, either an Eclipse app or Microsoft Project. So, and it's typically used a lot in different scenarios where, in education, if you got to give a room of students all access temporarily to an application and you're just using it for an hour, this is a great solution for those types of scenarios, or for apps that are, heavy burden, like CAD apps and things like that, where they require maybe CPUs with lots of memory and CPU requirements. So you can actually just set them up as a streaming app, and the user can use them through that virtual desktop, and then you don't have to buy them a heavy duty desktop to address those needs. It integrates with your Federation and Active Directory solutions, so you can embed all that security into it. It's got monitoring and programmatic control. We can auto scale a fleet, and it's all accessible via browser or client access. And then the storage, all the work that they do on that, it gets stored behind the scenes on your internal network. So nothing is stored on the local desktop as they're using this. They can actually, so you secure your data in that fashion as well. Like I said, you can stream it to any computer, so it works with, again, the different types of desktop or tablets that you may have deployed in your architecture. Again, you can access network storage and file shares. So you would set up the VPC, and it can have backend access to your network, on-premise network. There's an application management component of it, so you can manage the different applications and who gets access to them. And then it's got one code base, obviously, makes things a lot easier as well. So taking the example of a 3D design and engineering application, a user can easily go into it, launch it, use it for a couple of hours, and then when they're done, you'll stop using it, and then you're not going to be charged for that usage anymore. You'll just pay for what you use. So getting into the architecture, again, it gets deployed into your VPC, and then the AWS AppStream infrastructure takes over and creates the streaming endpoints that the users would be interacting with. And so they would make the connection, run the app, and be able to do what they need. And then we have backend architecture integration into your on-prem data center or to your AWS account. So looking at it from a pricing perspective, you have different ways to price it. So you got the on-demand, which is probably the most cost-effective one. Is you get charged 10 cents an hour while it's in use, and while it's sitting in a stopped status where it's just waiting for a user to interact, you're being charged 2.5 cents an hour. So that's probably the best way. But if it's an instance that everyone's using constantly and it's always on, then you can just switch to always on. It's the same cost. There's no additional cost. It just means that you'll be charged the full rate for a month at a time. Now there are usage fees per user, and that's related to the Microsoft SAL and CAL licensing that's required to use this technology. And so if you just went to the general public solution that AWS provides, you pay $4.19 per user. But Microsoft has different licensing terms for different organizations. So if you're a qualified school, university, or public institution, that $4.19 is now 44 cents per user per month. So quite significant cost savings if you qualify for that licensing tier. And then, of course, if you already have the licenses for the Microsoft RDS CAL licenses, then there would be no fee. We would just say it's a license included model, and then you would not incur those fees. The only fees you would be subject to is the usage fees above. So in review, AppStream provides a single managed app. It can deliver without managing hardware and infrastructure, and it can scale to any number of users. Getting to the Q&A, there's a question out there. What are the most common scenarios for using AppStream? Is it for desktop apps only? Can it work for client server apps? I'd have to say possibly yes for client server apps. I guess it would have to depend on the the specific client server app. I mean, obviously, if there's if you think, PeopleSoft has People Tools, which is a part of the application that could be streamed. But would you, stream a web server? I don't think so. It would be more the UI into that. So whether it's a web-based UI or some kind of client UI that a user has, that would probably be the most thing. And then Tyler or Bruce, if you want to add to that or clarify anything I said, that'd be great. And then moving on to the next question, if you use Excel with macros, how well does it support and run the macros? Well, so behind the scenes, you build the image. So there's actually an image builder, and I skipped over that. So you would build the image with Microsoft Windows version 2010, for example, or whatever release you want. And then you would install Microsoft Excel, the version you want, and it would stream just like it's the regular Excel. So I personally haven't run into any issues with it running Excel macros in it. The one thing you'd want to make sure is that if it's a heavy duty macro that uses a lot of memory, you might want to choose an instance that's more appropriate for processing the volume of data that potentially you may be using through your macro. But other than that, that should work with no issues. Any other questions or clarifications required?
I think I see a question about a Lawson ERP application. So for, I'm not sure if we're asking about for AppStream or for workspaces, but in general, the client components of these applications can run on workspaces, or we can stream the client component typically to a client.
Right. So that's the Lawson ERP question. There's another question. How does AppStream handle applications that calls another application, for example, a program that calls Word to perform a mail merge? Tyler, do you want to help with that question? I haven't tried that scenario. You'll have to unmute yourself if you want to talk.
Yeah, so you would essentially just define the application scopes that you need access to, and you would be able to launch multiple apps from AppStream, right? So if we needed to open both Outlook as well as Word, for example, you can do that. You just have to specify both applications.
Okay, perfect. Thanks, Tyler. The next question, are there a list of requirements to add applications? I'm looking at an on-prem developed desktop software. I'm pretty sure it can run any desktop application. Like I said, all it's done is virtualized the launch of the application on the Windows image. So if in theory that should work. Obviously, we'll have to test it to make sure there aren't any application specific issues or requirements that might prevent that. But my understanding and my experience is that most desktop apps can be streamed with little to no challenges. And Tyler, is there anything you want to add to that?
Just that we do have multiple customers that are running that today. Whether it's their own custom-made application that's a thick client, if you will, and we do have customers that are using browser-based applications. So they may have a web application that's an internal application, and then rather than exposing out the full desktop to an end user that's working remote, they'll provide them a browser that has a default session that points to that web app. And so those are some very, very common use cases. And just to echo that same point, right? Testing is key there to understand, what that would be. But essentially, if you can stream that app using RDP streaming, then typically that's going to be compatible with AppStream.
Great. So I think that takes care of the last question, unless someone has something to add before we move on. Okay, I'll move to the next. All right. So next we're going to talk about Amazon Client VPN, and this is probably the most relevant one in this current environment. So we work with a lot of clients. We actually have some clients that we work with, and the minute they move to work from home environment, everyone tried to log into the VPN, and the first message that popped up, it says, "Oh, you do not have enough client licenses provisioned to support all these users." So, a lot of companies have built VPNs or purchased their VPNs with some kind of anticipation of how many people will be working remotely. So you built your architecture to support what you thought you needed at the height of what you would scale to. And so we've had a lot of clients contact us and talk about this stuff. So the nice thing about the AWS Client VPN is you basically create your endpoint, you connect it to your AWS subnets and then back to your on-premise data center, and then users, you just set up all your different users, and then you can deploy it, and it auto scales. So there are no limits on the AWS side of the Client VPN in terms of how it gets deployed. And it's a quite simple thing to set up. The hard part is making sure all the back-end stuff is in place, making sure that we have your back-end VPC set up, your back-end VPN site-to-site connectivity established. Obviously, it's a little more complicated than what I'm stating here, but you get the idea. Is once we got the architecture built out, setting up the client VPN is as simple as logging into the console, going in and saying, "Hey, what's my VPN endpoint? What is my authentication mechanism? How am I going to authenticate users? And then which VPCs am I connecting to AWS? Which those VPCs then control how we access the backend resources within your network." So if you look at it from an architecture perspective, the client VPN is an endpoint. The users will have a client installed on their machines that they can connect to. It's publicly available. They can just go to a link, download it, and then log in. And then you would set up the VPC, and then they would basically be able to connect to your on-premise network or any internet resources that you have, or peer with other VPN or VPC applications that you may have running on a different account. You can connect to them using VPC peering. So very simple to use. And from a cost perspective, it's very cost competitive compared to some of the solutions I've seen out there. Basically, what you pay for is every hour that you actually use the endpoint. Okay, so for example, the endpoint itself is 10 cents per hour. And so, so if you look on an average usage, say a user use it for 76 hours in a month, then that's $17 for the endpoint. Okay, but the VPN connections, each individual user, it's 5 cents per user. So if a typical user uses it, so the only cost that really change is, the endpoint will be up. And then, so if you had 5 users, it would be 5 times 880. And that would give you your user cost. And then the 1760 would still be 1760. So it's fully managed by AWS. They take care of the deployment, the capacity provisioning, and any updates automatically. You are able to monitor and manage all your connections from a single console, and then you're just paying for your actual usage. And then, of course, you can secure it with your multi-factor authentication options, the same way you would do any other VPN provided solution out there. So very appealing, very quick to deploy. Very, this is something you could probably deploy in under a week if you got all the right people working on it together. So something to keep in mind if you are having challenges with VPN access. The next thing is the site-to-site VPN. So this is where we're connecting, the AWS data center to your on-premise data center. So then that gives you the ability to exchange data and then go through your private network up to AWS rather than going through the public internet or through a private connection to AWS. It's a highly available VPN service. It's got built-in failover, so you get 2 endpoints when you set up the first endpoint. So you got a primary and a secondary for failover. It uses secure IPsec and TLS tunnel capability technologies. There's full monitoring and alerting. It's a NAT translation layer. You're able to whitelist traffic on-premise or cloud subnets. And then, of course, if a site-to-site VPN is insufficient for your needs, you have a lot more, if you're transferring high volumes of data, gigabytes, terabytes of data, then a site-to-site VPN may not be the right solution for you. We may have to look at like a direct connection, which comes in, I want to say 5 and 10 gigabyte increments, so that you can have high volume exchange of data. We had one client we worked with, they were exchanging about 18 to 20 terabytes of data a day between AWS and their data center. So obviously that was a direct connect type connection that they used. But for most of our clients, a site-to-site VPN has been more than sufficient for their needs. We've had clients with 200,000 users over, we've had 4 or 5 different site-to-site VPN connections established for the different locations that we're connecting, and their performance was equal to or better than what they were getting from their users to their own data centers. So, works very well. And then there's lots of different options for you. So in review, we showed the client VPN. So if you do need the ability to connect users or get all these remote workers up and running quickly, we have a solution that's low cost and easy to deploy. And then the site-to-site VPN, the same thing for connecting your data center to the AWS data center. Can meet all the security and all that is industry standard. And of course, these are solutions that can be implemented pretty quickly with minimal effort from us or your team. Any questions about the VPN connectivity or any issues or things that piqued your interest in regards to that? And Tyler, feel free to jump in and add any additional color commentary that you see fit. Okay, no questions. I'll move on to the next section. So, oh, I can't move. Is that you, Nick? Oh, no, it's me. Okay. This should still be me. Did I lose access? Now we'll talk about Amazon Chime. Give me a second here. All right. Amazon Chime. So Amazon Chime is a cloud communication service that lets you meet, chat, and place business calls, including video and audio. It's allows you to do online meetings. You can do video conferencing. It has team collaboration abilities. And then you can actually place and receive calls using Amazon Chime. It's fully secure with administration. And the really important part of this solution is the ability to actually customize your solution using the Amazon Chime SDK. So if you need a custom solution for a telemedicine type situation where you want to provide some kind of solutions for hospital staff to communicate with their patients, the SDK is how you would actually go about building that solution and leveraging. So basically you have all the tools, all the pieces that you would need to build the solution, and then it's just kind of connecting them together in a way that best presents the way you want to interact with the end user community together. So it's used for telemedicine, education uses it for training students, student education. So you can have, set it up so the video shows this teacher, and then you have the PowerPoint presentation that's constant, and then you have the student chat area. So you can actually really, do some interesting things with it through the SDK. The standard stuff, being able to schedule meetings and handle meetings and coordinate meetings with it, just that seems to be a standard expectation of any type of solution like this. It comes with personalized meeting links. The joining experience is pretty straightforward. And then of course you can host it. It chooses the hosted region of the end user based on their location. So, it basically, AWS is using their global network of endpoints so that if I'm in Texas and you're in Oregon or Idaho, it'll use the closest endpoint for you to connect to the meeting and then connect us through the internal AWS network. So, the purpose for that is that it helps reduce lag time and improve the performance of the user experience. Okay. And then of course, you can do screen sharing, visual rosters, and record the meetings. The video conferencing provides a high quality, wideband audio and HD video for up to 16 people. It supports most conference room video systems. So if you needed to connect it to your on-premise conference room, you can do that through SIP or H323 connectivity. You got one-click video. You can do video sidebars, and then you can also, see picture-in-picture type stuff for presentations. From a team collaboration perspective, you can set up different chat rooms in your meeting. So in this example, we got a projects chat room where people can chit chat about the project, and so you can, schedule the meeting, for your users, and then just some smart presence, so if the user's at their desk. So this can be actually used as more of a a replacement for your VoIP system as well. If you wanted to use Chime as your primary communication mechanism, it can actually be designed to send and receive phone calls, so people can call into that user and they can have their own private number and things like that. So, the pricing, has pay-per-use pricing like everything else does on AWS. So it's $3 per day per user, or up to a maximum of $15 a month. Okay, so maybe the user only uses it once or twice a month, then they'll pay $6 for that month. The next month, if they don't use it, they won't pay anything. And then the call into or outgoing calls from the meeting are charged the standard call-in rates. They vary by country, so I just put the U.S. rates here. So if you had a meeting with say 10 attendees, then you'd be paying about 3 cents a minute approximately for those attendees to be on the call. So if it's a 60-minute call, then 3 cents times 60 minutes, $1.80 an hour, plus the $3 for the meeting. So about $4 or $5. So the nice thing about this, though, it allows you to track your costs by usage, by user at a very detailed level. that you can, then use that for your costing and budgeting and understanding of where the spend is coming from, and then you can plan for it, and at a very, like I said, detailed level. And then if you wanted a personal phone number for a user, that's $1 a month to give each user their own personal phone number, so people can call that number and it'll go right into their Chime meeting. So in review, Chime is, provides a rich set of communication options. It's built on the AWS architecture, so it gets, all the benefits of being in the cloud, with the ability to scale and support your growing needs. It's got agile pay-as-you-go pricing, and then, like I said, I think the biggest benefit, especially if you're going to be trying to build solutions for your constituents, the SDK gives you the ability to kind of create custom solutions to suit your prospective needs. So Q&A. So the first question was a leftover from the VPN discussion. Does the client VPN offer any quarantine and remediation features? This would ensure connected clients are patching to minimum security and anti-malware levels before allowing the client to fully connect. Tyler, did you want to take that question? You're on mute.
Yeah, so taking a little bit of a deeper look at that, typically, we're using a couple of different components for those things. So we could layer in some of those protections by utilizing things like guard duty, where those are pluggable solutions, right? So if you had another AV or patch management system, it really kind of depends on porting those back in. And so if it, the minimum patch level is something we'd be able to build into that solution. As far as the antivirus and quarantining of that would depend largely upon what you're using for the individual AV solutions.
Thanks, Tyler. And then the next question is, curious why you're not using Chime for this session. We've been using Zoom for quite a while. It was a solution we chose as our company standard, but definitely Chime would be a consideration in the future if we switch applications. Okay, I think Nick, you may have control.
All right. Sorry about that. So Amazon Cloud9. Okay, so what is Amazon Cloud9? So Cloud9 is a cloud-based integrated development environment that lets you write, run, and debug code with just a web browser. It includes a code editor, a debugger, a terminal, and it comes pre-packaged with a lot of the essential tools for popular programming language. PHP, so you don't need to install or configure your development machine to start new projects. Since Cloud9 is cloud-based, you can work on your project from your office, from your home, on a laptop, anywhere you have an internet connection. And as an architect, an administrator, and a developer, I spend a lot of time in Cloud9. It allows me to isolate my development resources from my personal stuff and even between projects and or clients. So Cloud9 is a full-featured editor that gives you the flexibility to run the development environment on a managed Amazon EC2 instance or any existing Linux server that supports SSH. This means that we can write, run, and debug the code without needing to install anything locally and keeping the versions to things that we want to have. The editor has included helpful features such as code hinting and code completion and step-through debugging. The terminal provides a browser-based shell that allows you to install additional software, do git pushes, or enter in commands. And it actually interfaces directly with a lot of the AWS SDKs directly right from Cloud9. So whatever security your profile has will also be shared into this environment. So if you wanted to stop resources, you can do it right from the command line in the editor. Cloud9 is very useful for collaboration. It makes it very easy. You can share your development environment that you prepare with your team with just a few clicks, and allows you to look at the same code together and allows them to edit as well if you would like that. And you can also add in a chat feature so you can chat through the editor itself. By default, it supports over 40 programming languages with the integrated debugger, but you can also add in any application that you would like. You have total control over the environment, and you'll have sudo access so you can do yum updates or install whatever software you want. One of the useful things about Cloud9 is it's integrated directly with all the Amazon services natively, and allows you to build serverless applications with ease. So directly in the console, we can actually code and provision serverless applications. This allows you to iterate your code directly without having to deploy and run with switching between the console and the editor. You can run the code directly in Cloud9. Cloud9 integrates with the development tools that Amazon provides natively, including CodeStar, CodeCommit, CodeBuild, and CodePipeline. So we can use build and create projects right from CodeStar and have it integrate with the development environment and manage and track the changes through the project, similar to Jira. This makes it easy, this makes it easy for people to see all the changes that are going on and add approval chains into the code as people are committing and changing codes into the branches. Here's an example of Cloud9 pricing. Now the instances themselves can be any size of EC2 instance. Typically you only need a very small instance like a T2 micro. So using that at roughly 176 hours a month might cost you $1.83 a month. But if you have an application that requires more horsepower, you can beef that up and you just pay the rate of the bigger instance. The other thing you pay for is the storage fees, and that rate is 10 cents a gigabyte a month. So in review, this is a fully functional coding and debugging platform that you can access from just a web browser. So you don't need to configure any tools locally, and you can actually start as many of these as you want. So if you want to keep them isolated from each other, you want a certain version of programming in one environment, and you want a different program in another, you can do that easily. And you only pay for it while it's running. It provides a uniform development environment for all developers, so you can provision one environment and then share that amongst the group, and everybody can use it. So they're all running on the same code, the same languages, the same versions. Q&A. Are there any questions about Cloud9?
I don't see any questions, but I do, like Cloud9 is probably the best part for us on AWS because that's where we do all our stuff. So all our teams are managed through the Cloud9 instance, so we can actually provision individual Cloud9 instance for each client, for each project, for each microservice that we want to deploy and develop. So it gives us great flexibility. And then in addition, that's where our users actually do all their training. So when we say, hey, XYZ user, you need to get this type of training, we give them a Cloud9 information instance where they can go and do everything they want. And then when they're done, they can blow it away and it'll be done, or we keep it there for history so they can go back and look at what they did to say, hey, how did I do that before? And they can go and look up their code. So it's very powerful. It's probably, like I said, if you're going to start working in the cloud, we highly recommend it. Cloud9 be part of the solution for your development teams to start working and developing. And again, all your code is stored locally, so it's all within your enterprise account. Okay, no further questions. Tyler, did you have anything to add to that before I move on?
Nothing for me.
Okay, thanks. All right, so we're going to just do a brief view of some other applications that are available on AWS. We're not going to spend a lot of time of them in this session, but but I just want to make you aware of them so that if there is an interest in discussing further, we can certainly schedule more detailed dive discussions into the subject areas. So Amazon Connect Contact Center. So this is more of a long range thing. It's going to take a little more effort to implement, but you can actually virtualize your contact center using AWS. So it's an omni-channel experience for agents and customers. It has intuitive graphical contact flow builders built into it, so you can actually create your own custom workflows to direct how users. So if you think of like a 911 call center or 411 or whatever contact center, or your healthcare contact center, this might be a great solution. And it uses a lot of the same technology that you've probably seen in like Amazon Chime and things like that, but it's kind of pulled together into a solution for contact centers. And I think the other big thing is how AWS manages their own contact center. It's the same technology that AWS is using to support their own customers. It provides high quality audio and video recording capabilities, and then it can integrate with CRM solutions that you may already have deployed, whichever ones you may have. And then it has an AI powered speech analysis and analytics tool built into it. So about it's 100% cloud based. The agents can work from anywhere, so it's just an app that's on their local PC that they can fire up from home or from anywhere where they're working, and it's a complementary AWS service. So this is more like a SaaS type solution on AWS than it is a tool. And then of course it follows the same pay-as-you-go pricing model. The other application we wanted to touch base on and just make you aware of is Amazon Workmail. It's a secure managed business email and calendaring service. It's basically Microsoft Exchange in the cloud, but it works with all your regular Microsoft Outlook, iOS, Android browser, or any third-party email applications that you might have installed locally on your machines, and it seamlessly integrates with Microsoft Exchange Server. One of the big things is journaling, tracking all the emails coming in and out for archiving purposes, for compliance purposes. All that stuff is built into it, so then you can connect it to your compliance applications on premise or your email, or you can actually build email flow rules so that you can direct emails based on conditions that you identify, built-in spam and virus protection. And the other thing is you get a mailbox, a large mailbox. You get 50 gigabyte email boxes. I remember a day when I was working at some other companies, my email inbox was like limited to 250 megabytes. And in today's world, that's probably insufficient for a lot of people's needs, and especially with the volume of email. So having 50 gigabytes available to you as an end user is very, very powerful and good from my perspective. So anyway, so we just wanted to make you aware of that application. We can do a deeper dive into the features and functions in one of the future sessions. We're running up to our timeline here, and didn't want to go too far over our what we allocated. Brian?
All right. Yeah. This is Brian again. I want to thank you all and just try to kind of wrap this up. We've got a couple more slides, but we're getting near the end here. It's understated to say we're undergoing unprecedented times in our country and across the world. Typically, remote work solutions are not something you think about when you think about the cloud. And we wanted to share some of the things that we use internally, as well as some ways that you may be able to adapt and adopt some solutions that will help you get through these times. There's still a lot of questions about how long this is all going to last. So just as we wrap up, there's a lot of different remote working solutions that Amazon offers. They all are cloud solutions that will scale on demand as worker load requires. New solutions may be ramped up very quickly. We're talking minutes, hours, or days versus a capital expense that needs to be budgeted, and you've got to procure equipment if there's even enough equipment in the pipeline to make that happen. So all the solutions are pay as you go, and they all offer a very agile way for you to address these unprecedented times, and they all will help you maintain their infrastructure security based on the security of the cloud that's already built into everything that Amazon does. So personally, I want to thank you for your time and pass it back to you, Dave.
Oh.
Yeah, actually, I think it's back to
Back
me.
to Bruce. Yeah.
Okay.
And thank you. There we go. All right. Well, thank you all. On the remote worker, there are some services that are in a promotion right now. I just wanted to mention Amazon Chime is for online meetings and video conferencing through June 30th is at no charge for everyone on this call and for new customers. Additionally, Amazon Workspaces on beginning April, in April all the way through the end of June will be for no charge at all for up to the first 50 users. And Amazon Connect, the call center software, it is eligible for AWS free tier. So it is free for use for 12 months. Free is always a very good price. And so I thought I'd just mention those things for those particular services. Also, the question about Zoom, why are we using Zoom instead of Chime? I would like to just mention also Zoom is powered by AWS. So it's a SaaS service. Chime is a direct one as from AWS. Zoom has a service as well. Because this is a workshop, there were some features that we thought would be more optimized for Zoom. Both are great products, but I just thought I'd mention that on the pricing. Next one up is we've got 3 other workshops that are coming up here. Each of these are Wednesdays now. So we moved this remote worker workshop up because the virus situation, there was some requests of saying, hey, can we get that content early? Normally it would come in on day 2 or day 3. So on Wednesday, next Wednesday, the 15th, we'll go over the AWS core services and architecture. This foundation. So talking about compute, network, storage, and infrastructure, code deployed infrastructure. And we'll also do a double click on security and identity management, and then on compliance. The following Wednesday, April 22nd, we do have a talk on automation. So using automation to be able to deploy these environments using DevOps and tools to be able to do so. We'll also talk about migrating workloads. So if you have existing applications, what the methodology is to be able to move those things over to be able to run on the cloud. And finally, on April 29th, our 4th day, really is dedicated to advanced analytics and machine learning. So we'll show how to set up data lakes and then run analytics against it, and to be able to more, and then to be able to use machine learning and artificial intelligence in order to have better data driven decisions, if you will, at a high level. Certainly some of the stuff in contact tracing will be, as an example, a good example of how this technology is used with the virus. So, okay. And with that, what I'd like to do is go ahead and close out this workshop today. We are running about 30 minutes early, so we got you back early here. I do want to thank everyone for the attendance today. And the next 3 workshops will be more technical as we drill down into the architecture and implementations. Your feedback is greatly appreciated. So if you receive a survey from us, appreciate the feedback. We will tune this to whatever direction you want to go for the next three sessions. So give us your feedback. Let us know how we can optimize. And I thank you for your time today. And with that, that's the ending of our workshop. Thank you.